So this is question 16. Find BC first of all in terms of A and B. So we're going from B to C here. So B to C, this is 16A, is the same as going from B to A, then from A to O, and then from O to C. So B to A is minus 6B, A to O is minus 6A, and then plus 12B. So you're going to end up with minus 6 plus 12 is just 6B, minus 6A. Part B then says that X is the midpoint of CD, Y is the point on BC extended, so BC is here. So if I put a point, say Y there, such that BC to CY, so BC here being 3 amounts, to CY being 2 amounts, prove that O, so O, X and then Y lie on the same straight line. So the first thing to sort of pull back is that BC is obviously something we've worked out already, which is 6B minus 6A. So that's B to C there. I'm wanting to prove that OX and Y are all on the same setup. So if we then go C to Y, well, C to Y then is if we divide this by 3 and then times it by 2. So divide it by 3 and times it by 2. We'll then get out what C to Y is. So C to Y there we've worked out. If we work out then what O to X is, so O to X, O to Y as well. So O to X first of all. Well, O to X, how can we get from O to X then? What do we need to do there? We're going to go up to 12B, and then if we add the C and the Y together, that would give us OY, but OX itself, well, that's halfway between what? C and D. How do you get from C to D? Well, you know that, do you know what the E movement is? Do we know what the D and E movement is? Well, the D and E movement here is 6B. And OE is the same as BC, which we've worked out already, which is 6B minus 6A. So OX, this value here, well, let's work out what CX first of all is. So CX is going to be minus 12B, work it around this way, plus 6B minus 6A, plus 6B. So that will cancel out all the B's totally, which will just leave you with minus 6A. So minus 6A is there. Sorry, I didn't spell that, that's crazy. I've obviously proved that already. So minus 6A is working down there. So C to X will be half of all of that. So with half it will get minus 3A there. So that's C to X. So O to X then, just to come back to O to X, I'll put that underneath actually. O to X then is going to be 12B minus 3A. So we're combining there and there. And then O to Y, well, that's going to be 12B, then plus what CY is, which we worked out here. And that will give you 16B minus 4A. If we take out a factor of 4 there, I get 4B minus A here. If I take out a factor of 3 here, I get 3B minus A here. Sorry, 3B minus 4B minus 3A. So we've proved that OX is the same, OY is the same. So the connection between OX and OY is that it's 3 to 4, hence proving that OX and Y lie on the same straight line at that point. Question 17. We have a graph here called fx. The only vertex of the graph is at 1, 2. Write on the coordinates the vertex of the curve with the equation fx plus 3. Well, plus 3 means that we're going to add 3 to the y value. So the vertex will then move up to here. So 17ai, the vertex will move 3 up, so it'll be 1, 5. Part 2. Minus 2 inside the bracket means it's going to move in the x direction, the opposite way you would think. So it'll move here, which will be 3, 2. The curve is transformed then with the equation y equals minus fx. Describe the transformation. Well, it's been reflected in the x-axis. So part B there. Because every y value was these values originally. So for example, here was the original point. It stays at 1 on the x, but the y then comes down to minus 2. So it's a reflection in the x-axis. And then question 18. The diagram shows a net. The net is a sector of a circle. The radius of the circle is so on, and we'll call the angle of the circle. The next choose to make a cone. Calculate the vertical height of the cone. Give your answer to 3 significant figures. So what are we going to get here? How do we work out the height of a cone? Well, you need to go back to the formula sheet about a cone and what you can say about it. So if we go to the front, we've got 2 things about a cone. First of all, the volume of it is equal to 1/3 pi r squared h, and the curved area, so the actual area of the shape, is pi r l. So what can we do then? You sort of start looking at it and going, it's a sort of thinking question. You may be thinking, okay, we can work out the area, pi r squared. That may help us out slightly. So we could look at doing that. Maybe we use one of these equations. So you start thinking, well, actually what we're going to get a curve, a cone that looks something like that. I'll slightly draw a better version than what I've just done there. So the cone, when it's turned up, is going to look something around about like that. So add the edges in. So what can we actually do? Well, we could work out maybe the distance around the bottom. That may help us to start with. So it'd be 220 over 360 because it's part of the circle. If we work out this distance here, and then it's times by pi times d. So pi times the diameter, which is going to be 20.6. So I'll put in my calculator. I get 21.572. Then when I've done that, I'm then going to think, well, actually that gives me the whole distance around here. So that's the area. Sorry, not the area, the distance around that shape. Well, if I could work out maybe the radius from that, I know that this is 10.9. So if I then try and work out what height h is, I can use Pythagoras. So r, well, if I've got a circle and I know the circumference, I can then divide it by 2 pi. Because 2 pi r is the distance around a circle. So divide it by 2 pi. That will give me then the radius. So the radius of this shape is 2.43 recurring, which is this point, and then you've actually got a right angle triangle, 10.3 there. This is 3.43 recurring. So we're going to square the 10.4, square the 3.43. So using Pythagoras, it'll be the hypotenuse squared is equal to the two sides squared and added together. So h squared will be 10.3 squared minus 3.4 squared. So that will then give us 94.2, so h squared is 94.302, and then we square root that to get what h is. Which will then give us 9.71 to three significant figures, 9.71 centimetres.